This is a solution to a problem 6.2 that I'll leave up on Connect, and you can take a look in there if you care to. But I've put all these questions up there as an ungraded assignment. And you can go in there and you can try it, but I'm going to show you how you do it here. I'm going to save you the time to go over there and look at it. Okay, so problem 6.2. This is about chapter 6. I was asked to do a video about the learning curve. And so problem 6.2 is the easiest of them all. It gets us started to understand what the learning curve is all about, which we went over in class. Company Z is just starting to make a brand new product they have never made before. They have completed 2 units so far. The first unit took 12 hours to complete, and the next unit took 11 hours. Based only on this information, what would the estimate of the learning percentage be in this process? And they're telling us to round to the nearest decimal, to 1 decimal place. The theory here, learning curve theory, states that as the output doubles, the time to perform a task decreases by a fixed amount. Every time you create twice the amount of units that you already had, every time you double, you can take a look at how long it took you to do that, and it should represent the time it took, should represent the learning curve. Okay, I'm going to switch over here to OneNote to draw a picture of what we're talking about. I did this in class, but you should be able to see this. So we have a graph. Whoops, this is not going to be straight. I'm trying to use a mouse to draw straight here. Okay. So these are in the chapters how it normally works. This is going to be the time it takes to do the production of your first unit, your second unit, your third unit, your fourth unit, etc. I'm going to go out to 8. Okay. So let's say we've created our first 10 units. Now it could be a big satellite. It could take a year, 18 months to do a satellite, or it could be a widget where you're just putting 2 screws together or something like that. Okay, so the time here could be in different scales. It could be in seconds, it could be in months. I guess if you even do space stations, it could take decades. Okay, so the first one we're saying takes the longest. The whole idea here is that the more you do, the faster it takes to do each one. So we're going to draw a dot for how long it took for each of these units. After we did the first one, the second one should show some improvement in time, a reduction in time. So therefore the cost of that product should go down. We have less labor content in there. Okay, so then we go to 3. The third unit took this much time right here. The fourth unit might have taken this. Fifth unit, sixth unit, seventh, and the time keeps diminishing for each additional unit that we make. And we said every time we double, so when we go from 1 to 2, 2 to 4, 4 to 8, and then 8 to ... 16 out here, every time we double, if we look at how long it took to do that nth unit compared to the one that's half the n, we should see that we're experiencing the learning curve. Okay, so from when we go from unit 1 to unit 2, we should just be able to start taking a look at what the learning curve is. Okay, so in our problem, I'm going to go back over here. In our problem, they're trying to get us situated here. It says the first unit took 12 hours to complete, and the second one took 11 hours. So I'll do that over here. So the first one, here's 1. And here's, I guess we'll go down the page here. So the first unit that we made took 12 hours, and the second one took 11 hours. Okay, and the way that we compute that is, what was the learning curve? We doubled the number of units from 1 to 2, so we should just take the time it took was 11 divided by the time it took for the first unit. Okay, and our answer should be 91.7% if we round. Okay, so that's 91.7. And then what we would do is we'd end up making our third at some time, and we build our fourth. Okay, so what you could look at here is say we should experience a 91.7% learning curve from 2 to 4. Okay, so we should be able to say this takes, if it held perfectly, which it doesn't in real life, we have data a little bit off the curve here, but in general it should work. Okay, we should be able to calculate how long it would take to do number 4, and that would just be the percentage times the second unit, And so the fourth unit should be able to come up around 10 hours, 10.1 hours. And the same way, if we did 5 and 6 and 7 and 8, if it were a perfect world, we're going to take this, I'm going to move it over here because that's the time. I put it in the wrong place maybe. And what we're going to say is 8 should take 91.7% of time of the fourth unit every time we double. Okay, and so the eighth unit should take 9.24 hours, I guess we're talking about. It's hours. Okay, so this problem is in hours. You have to look at the units that they're using. It doesn't really matter too much. You got to be a little careful about that, all right? Now, the thing to remember is, and they don't give us this information, but if the third one took 10.5 hours, let's say it took 10.5, well, if we doubled the number of units, if we built the fourth and the fifth and the sixth, and the sixth one took, let's just put in some estimated numbers here. So 10.8, we're going to go to 9 point, let's make it 9.8. I'm going to make this one 9.4. I'm just making very rough estimates here. I'm going to make this one 9.55. We don't really know these numbers, but I'm just populating them, and I want to show you something, that we're able to go from 1 to 2. So if I click that, we can go from 2 to 4, that doubles, and we can go to 4 to 8, that doubles. And I'm just going to paint them for a sec. Okay, so I'm going to paint them yellow. Those are the ones that we're using to establish the learning rate. Okay, but don't forget that we can do 3 to 6. Okay, so 3 to 6 is a doubling. So if we actually knew how long it took to do 3, if they gave us that information, let's use orange for that. Okay, so orange. So 3 to 6 is doubling. And then if we had times, this is the 9th unit and the 10th unit, so if we knew what the time was for from 5 to 10, if we had a table like this, and we were allowed to calculate the learning curve here, we could say that the 10th unit is going to equal the learning curve, which is right there, times half the number produced would have been 5. If we do the learning curve times that, we can calculate, predict, forecast that the 10th unit would take 8.98 hours. And that's just based knowing the learning rate, just using the first two. So the end of the problem was way back when we just calculated 12 versus 11 hours and we figured that out. But I just wanted to show you how it works. Don't forget that you can get a better estimate of what the learning curve is by using as many of these relationships as possible. Okay? Because the corollary to that is, let me copy these. Let's assume we're going to do something different here. And I just want the values, I don't want the coloring on there. Okay? Alright, so if we did have straight numbers in here, suppose they had given us a table and it looked like this. What I just want to do is fill out the table here. 9.1, okay? Control C. And I'm going to put those values in there. And I'm just going to clean them up so they're not as messy. Number, and we'll use how many hours? We'll just use one decimal place there. Just want to clean them up a little bit, okay? So the other kind of problem that you're going to get, or you can see, is if you were given these numbers, what you would do is you would calculate every place in the short table where you see you experience a doubling of the units produced. So from 1 to 2, we could still do that. Now remember, we calculated these things. I estimated some of these and we calculated some of these. But this will suffice. Out of a table of 10 numbers like this, how many different learning rate calculations can you make? Well, I gave you the answer. The answer was you can go from 1 to 2, that would be 1. You can go from 2 to 4, that would be 2. You can go from 4 to 8, that would be 3. You can go from 3 to 6, that would be 4. and then you can go from 5 to 10, and that would be 5. See, each of those relationships is a doubling in the number of units. So if you can get a better estimate by averaging these numbers out, okay? So how you normally would do it is if you had some rough numbers like this. These were readings off a production line, okay? The first thing we would do is we would look at the doubling from 1 to 2, okay? And we would calculate that, which we already said was 0.9 or 92.7%, okay? So we can't do anything about calculating at the third one because we have no 1.5. There's no such thing. These are just whole units here, okay? But we can calculate from the doubling of 2 to 4, and that's going to equal this number over this number. Now that's going to come out precise because I calculated it over in this table. In real life, these are going to vary. It's not a perfect world, but they do follow this generally, this grid or scale that is decreasing, but the change decreases over the units produced, okay? So since we have 8 down here, we'll go ahead and we'll say, what's the learning curve between 8 and 4? And we calculate 0.94 or something. Okay, see, when we got down here, I started interpolating numbers sort of ad hoc down here, and they don't fit the curve perfectly. This is like a real-world problem now, okay? So we have another estimate or calculation of the learning curve, and some people would stop there and go, gee, I've made all the calculations I can. Well, what you can do is you can come into here, and 6 is the doubling of 3, so we'll take the reading here, 6 over 3. Let me do that again. It's going to equal that over that, okay? And we get 90% there, okay? Right. And what I'm going to do is I'm going to clean up this column. I'm going to format it by percent, and we're only going to use 1 decimal place for that, okay? So I'm just reformatting it. The numbers are still there, okay? So what we did is I just showed from 3 to 6 there's a doubling, so we can calculate it. We took the time it took to do the 6th, and we divided it by the time it took to do the 3rd, and we came out with 91.0%. And in a list of 10, there's one more number that we could use. We can calculate here, we can calculate the learning curve there, and then your final learning curve is going to be the average of all these. And the reason I'm reaching for more calculations is because, I'm going to click these first, the more numbers you have, the more accurate your learning curve is going to be. Instead of 3 points, we actually can extract 5 points out of a list of 10 to get that. Now, if we hadn't added those other 2 in here, I'll show you how the calculation will be different, because without the other from 3 to 6 and 5 to 10 calculations, this would equal the average of only this and this and this. And you can see how these numbers are different. And what we want to do is add in as many points as we can. So the first one is, we'll call that the learning curve with 5 in there. And the second one was, if we didn't pursue that and we only used 3 points, we would have had a less accurate number. And that goes beyond what this question is, but I gave you this explanation because this is the next order of complication when you look at these types of problems.